Okay, everybody, welcome back to math class. Today we are doing Module 1, Lesson 8. And this lesson is about estimating quantities. Now, estimating, one of my favorite things because it means I don't need an exact answer. Oftentimes when you don't need an exact answer, the math is easier. A lot of it is mental math. So I kind of like estimation. So, in lesson 7, what lesson 7 showed us, lesson 7 is going to help us with this. We learned how to use exponents. A little reminder of the last lesson. How to use exponents to show place value. Using exponents for place value helps us estimate, helps us do math. This skill of using exponents for place value helps us find approximate solutions to problems. Now, the word approximate is the same one as estimate or about. It means close, not exact. Now, of course, the closer you are, the better it is. But approximate, you just have to get close. You don't have to be exactly on the ball. So let's look at an example. Example 1. Remember, I am asking you to follow along with the notes, copy them down on a piece of paper, copy them down in a notebook, so you have something to refer to. Example 1, let's talk about New York City. Instead of writing out New York City, I'm going to put NYC. That's New York City. The New York City population in 1723, before the United States was even a country, the population of New York City in 1723 was 7,248 people. The NYC population about 150 years later, in 1870, was 942,292. The question is, how many times greater was it? And that is the question, but there's a fun word I'm going to throw in there. About how many times greater was the population after 150 years? Now, the fun word here is about. Normally what you do, if you do not say about, you'd have to do the population in 1870 divided by the population in 1723. You can see those numbers do not do a lot of work. In fact, that is long division style, going to take you quite a while, and you're going to wish you could use a calculator. But this way, when we can do about, approximating our work makes it easier for us. So let's first approximate 1723. 1723 was 7,248. What is that close to? Well, to do this, let's use our skills from lesson 7. Let's round up to the next place value. Just like we did in lesson 7, we're going to say the next place value higher than this is 10,000. Because 1,000 is too small, 10,000 is the next one up. And 10,000 is 10 to the 4th, because it's 4 zeros, it's 10 to the 4th. 4 zeros means 10 to the 4th. So our approximation in 1723 the population was about 10 to the fourth. In 1870, there was 942,292, which round up to the next place value. We need to round up to 1 million because 100,000 is too small. We need to go up to 1 million in order to get above this number. And 1 million is 10 to the sixth. So now we do some math. How many times greater was 1870 than 1723? Whenever it's asking how many times greater something is, you need to take the bigger one and divide by the smaller one. So we're going to do 1870's population divided by 1723's population, which 1870, remember, is 10 to the sixth, or about 1 million. 1723 was about 10,000, 10 to the fourth. Now, already you should know from earlier lessons in this module how to solve this. We have the same base, and when we have the same bases divided by each other, we subtract the exponents. We do 6 minus 4. So this is 10 squared. And 10 squared is 100. So our solution is 100 times as many. So we say 1870 had about 100 times more people than 1723 in NYC, New York City. That's your answer. So it's about 100 times. Let's give you some time to practice this. What I'd like you to do, go to your page, go to page 77, and let's look at exercise 1 on page 77 and practice this skill a little bit more. I'll go to my exercise 1. This is all about the Federal Reserve and debt. Okay, so Federal Reserve, which is like kind of like the bank of the government, states that the average household in January 2013 had $7,122 in credit card debt. That means every home in the country, every family had about $7,000 of credit card debt. About how many times greater is the U.S. national debt? The United States, the country, owes money. So a household had 7,000. The country has debt that big, which is more than $16 trillion. And that was in 2013. It has gone up. First, it says rewrite each number to the nearest power of 10 that exceeds it. Remember, we did this in lesson 7. Power of 10 means place value, and exceeds means greater. So we need to write each number to the greater place value. So let's start with the household debt. So I'm going to put HH for household. Households owed about $7,122, which we have to go to the place value that's greater. That's going to be 10,000. Because 1,000 is too small, so we have to go to the next highest one, 10,000. And 10,000 is 10 to the fourth. Now the U.S. debt, 16 trillion, 755 billion, 133 million, $9,522. Now the place value that this goes up to, 1 trillion is too small, 10 trillion is too small. To estimate, we have to go up to 100 trillion, which looks like that because 10 trillion did not exceed it. 10 trillion was not greater, so we need to go to the next place value, which is 100 trillion. And 100 trillion, instead of writing all of that, we can just say 100 trillion, count the zeros, 10 to the 14th. Then we are supposed to compare how many times greater is the national debt. So we have to do U.S. debt divided by the household debt to figure out how many times greater the U.S. debt is. U.S. debt was 10 to the 14th, approximately. Household debt was approximately 10 to the 4th. Now to divide this, we use the exponent rules we talked about in the first part of the module. Same base, so we can just subtract the exponents. 10 to the 10th. So the U.S. debt is 10 to the 10th times greater than every house's debt. By the way, 10 to the 10th is that number. The United States owes $10 billion more than a single household. So we can summarize this by saying the U.S. debt is about, make sure you say about because we rounded, it's approximate, is about 10 to the 10th times greater, which is a ridiculously huge number. That just shows you how much money the government owes. But the question is, could we have had a more precise answer? Could we have had a more precise answer? Because we are saying right here that it's 10 to the 10 times greater. How precise, how close is that number where if I take this and divide by this, how close is our approximation to the exact answer? And I'm going to tell you, it's not very close because look how much we had to change when we approximated. When we took the household, we started with 7,122. We jumped up to 10,000. That's a pretty big jump. That's almost a $3,000 jump. That is not a super close approximation. It's okay, but it's not super close. But look here, we had 16 trillion, and we estimated all the way up to 100 trillion. When we estimated, we went up almost $84 trillion. That was a huge jump up. So even though this is an approximation, it's not a super close approximation. We can get closer. So remember, approximations have value if they're close. For example, if I were to say you were about 10 years old, you might get a little bit upset by that because you're like, no, I was 10 years old a while ago. If I say you're about 13, that's a little bit better. Do I know your exact age? No, but I can make an approximation. Is 10 a good approximation? It's okay, but 13 might be better. If I knew your exact age down to the month and the days, that would be a great answer. But remember, approximations are useful if they're close. This was a big jump, not very close. Let's look at another example and see if we can do better with our approximations. We're going to go back to New York for example 2. Only this time we're going to do New York City versus New York State. So New York City, we're still comparing populations. New York City has, when they made this book, 8,336,697 people. Now we could approximate and say, okay, that's going to be close to 10 million. But if we say it's close to 10 million, we're going up almost 1.7 million. We're going up almost 2 million to jump up to 10. What happens if I jump down to 8 million? So instead of jumping up almost 2 million to 10 million, I'm going to jump down to 8 million. This way I'm only jumping down 336,000. That's a smaller jump than jumping up to 10. And New York State's population when they made this was 19,570,261. Now if I use lesson 7's rules, 10 million doesn't work, so I have to go up to 100 million. But that's a huge jump. Adding 80 million is ridiculous. So instead of going up to 100 million, I'm going to make a better approximation and just jump up to 20 million. Now this is going to be a little bit different because you used to just tens. Now we have something else other than a 1. The reason we did lesson 7 the way we did it was because it was super easy. Looking at exercise 1, our answers were only tens. Everything was estimated with a 1. Now we have an 8 and a 2. The 1s aren't there anymore, so it gets a slightly more complicated. But let me show you how to do this. Let's still turn it in with an exponent because the exponents are easier to do our math with. 8 million is 8 times 1 million. And 1 million is just 10 to the 6th. So instead of having 10 to the 6th by itself, I just have 8 times 10 to the 6th. That's still a million, so this is 8 million. The 20 million for New York State is a 2 times 10 million. All I did is I pulled the 2 out. And 10 million is 10 to the 7th. So you see now, this is just like lesson 7, except for I'm pulling out a number in the front of the 10 with the exponent. I'm just pulling out a number from front. The math works out the same. So let's see. We want to know how many times greater New York State is. The question is, how many times greater is the state population? Now, I just noticed something. I don't know if you noticed something. I left out a word in the question. I'm going to pretend I did it on purpose. But this word, because we want to approximate, about how many times greater is the state population. So because of that word about, I can use these estimates. So I'm going to take the state population. I'm going to do the state divided by the city to find out how many times greater. The state was 2 times 10 to the 7th. The city was 8 times 10 to the 6th. Now pay attention here because I'm going to do some math that you've done with fractions before with multiplying fractions. I'm going to pull the numbers. I'm going to separate the numbers and the exponents to make it a little bit easier to do the math. I'm going to separate them to like terms, essentially. Now, 2 divided by 8, you should be able to reduce that fraction to get 1/4. How do we simplify this? Well, you remember the rules from the first part of Module 1. Bases are the same. Subtract the exponents. That gives us 1/4 times 10 to the 1st, which is 1/4 times 10. Now to do this, it helps if you know that 1/4 is 0.25. So we have 0.25 times 10. And when we multiply by tens, the number gets bigger one place value every 0 we have. So there's 1 0, so we jump up one place value. And the new decimal is right there. So the answer 0.25 times 10 is 2.5, which tells me that the state population, I'm going to put state pop, is 2.5 times the city pop. And all of that is fraction math with exponents, just dividing with exponents. I'm going to leave that there for a second. Pause the video if you need to look again, check your work, make sure you understand every step I did. If you do not understand every step, it might be a good idea to go back and rewatch this section or to ask me for some more help. The next thing we're going to do after this is we're going to go back to our exercise page, and we are ready for exercises 2 through 5. So we're going to do the rest of the exercises right now since you are ready. So looking at exercise 2, says there are about 3 million students attending school, kindergarten through 12th grade, in New York. 3 million students in school in New York. Express the number of students as a single-digit integer times a power of 10, which means it wants us to turn 3 million into a single digit times a power of 10, times a place value. So we look, here's how we do this one. We have 3 million. It wants us to make this into an exponent so that it's easier to work with and easier to solve the problems. Now, 3 million is just 3 times 1 million. And 1 million has 6 zeros, so 1 million is 3 times 10 to the 6th. And that is the form it wants us in. We have a single-digit integer, which is 3, and a power of 10, which is 10 to the 6th. So we did exactly what it wanted. We changed 3 million to a single digit times a power of 10, 3 times 10 to the 6th. This is 3 million. This is also 3 million. Same number, 2 different ways to write it. Same number, 2 different ways to write it. Now the second part of exercise 2 says the average number of students attending a middle school in New York is 8 times 10 squared. How many times greater is the overall compared to the middle school? So we need to do all schools in New York City divided by just one middle school. All New York City divided by middle school to figure out how many times greater all New York is. Well, all New York, remember, is written like this, 3 million, although why am I writing it 3 million like this? Because the math is easier. The math is easier when we have exponents. You can do a lot of it's mental math when you can use exponent rules. The middle school is right here, 8 times 10 squared. Right there. Now we need to solve this, figure out how many times bigger than New York City is. So let's separate the terms. Oh, 10 squared, sorry, my bad. Now it helps if you know 3/8. If you don't have 3/8 memorized in your head, it's okay, use a calculator, but 3/8 in decimal form is 0.375. 10 to the 6 divided by 10 squared. You know the rules by now, just subtract the exponents. So we get 0.375 times 10 to the 4th. Excuse me. This is 0.375 times 10 to the 4th is a 1 with 4 zeros. And there's 4 tens, which means we jump 4 place values. 4 tens, 4 zeros means we jump 1, 2, 3, 4 place values. The new decimal is there. What about this empty space? Let's put a 0 there. So now the decimal is here. So our answer is 3,750. So New York City, the overall students is 3,750 times greater than one middle school. Shows you how much bigger New York City is than just one school. Let's move on to exercise 3. Remember, if you are struggling with any of this, ask questions, rewatch the video, try one of the other videos linked in the lesson. Make sure you understand how to do this math. Number 3, a conservative estimate of the number of stars in the universe. So stars in the whole universe is 6 times 10 to the 22nd. A human can see 3,000 stars at night with your eyes. How many more stars in the universe? How many times more stars in the universe compared to the stars a human can see? And here's the magic word, about. So we're allowed to estimate. So we have to do all the stars divided by the ones you can see with your eyes. So all the stars is 6 times 10 to the 22nd. You can see 3,000 with your eyes. So how many times more stars are there than what you can see? Let's turn the 3,000 into another one with a power of 10 with it so that the math gets easier for us. 3,000 is 3 times 1,000. And 1,000 is 10 to the third. So 3,000 looks like that, 3,000 looks like that, 3,000 looks like that. Why did I write it like that? Because now the math is easier. I separate the sections, 6 over 3 times 10 to the 22nd over 10 to the third. 6 divided by 3 is 2, and you know right here that we take the 22 minus the 3. So how many times more stars can you see? In the universe, there is 2 times 10 to the 19th times as many stars as you can see. That is a lot of stars in the universe that we cannot see. 2 times 10 to the 19th times as many. Now, the concept in taking the numbers in, figuring out what to do with the numbers, where to put the numbers is one skill. I am more concerned that if I give you this equation, can you get that answer? If I give you this, can you get that answer? If you can, then you're doing well. Exercise 4. The estimated world population in 2011 was 7 times 10 to the 9th. Of the total population, 682 million of those people were left-handed. What percentage of the world's population is left-handed? Okay, so to do this, we need to take 682 million, and let's use our approximately word and estimate that a little bit. 682 million looks like that. Now I'm going to estimate and say, you know what, that is pretty darn close to 700 million. And 700 million is 7 times 100 million. And 100 million is 10 to the 8th. So I take this, say it's close to 700 million, and then I just write 700 million with a place value using a base 10. So this is about how many left-handed people we have. To find the percentage, we take the left-handed people and divide by all the people. That's how we get a percentage. Let's separate the numbers and the exponents. 7 over 7 times 10 to the 8th over 10 to the 9th. 7 over 7 is just 1. And 10 to the 8th divided by 10 to the 9th is 10 to the 8 minus 9. So now we get, well, 1 times anything stays the same. So this is just going to be 10 to the negative first power. 8 minus 9 is negative 1. And the 1 means it just stays the same. Now you know from an earlier lesson that 10 to the negative first power is the same as 1 over 10 to the first, which is 1 over 10. So 1/10 of the world's population is left-handed. That is a fine answer, except for it did not ask for what fraction of the world is left-handed. It asked for what percentage is left-handed. Well, 1/10 turns into 10%. Hopefully you remember your percentages from 7th grade. So about 10% of the world is left-handed. That means 90% is right-handed. I am right-handed. Are you one of the 10% that is left-handed? Very curious. So hopefully, like I told you, I will give you the equation most of the time so far, and we're going to start slow. I'll give you the equation. Can you start here and end here? Can you do the math and get from this step to that step? If you can, then I'm happy. Exercise 5. The average person takes about 30,000 breaths per day. Express this number as a single-digit integer times the power of 10. So we need to turn 30,000 and give it to a power of 10. Well, this is 3 times 10,000. 10,000 is 10 to the 4th. So 30,000 turns into that. That's the first step. So you take 3 times 10 to the 4th breaths every day. And the average American lives 80 years, or about 30,000 days. How many breaths will they take in their lifetime? Well, we have to do breaths in one day times all days in your life to figure out how many times you breathe in your life. We take how many times you breathe in a day and multiply it by all of your days in your life. So this is how many breaths you take in a day. So that's 3 times 10 to the 4th. How many days do you have in your life? Well, that's also 30,000. And 30,000 is 3 times 10 to the 4th. So this is the breaths in a day. This is how many days you have. We multiply these together to figure out how many times you breathe in your life. Because it's all multiplication, I can just write it like this. And because it's all multiplication, I can use the commutative property to move things around so that like terms are next to each other. And I can use the associative property to do things in whatever order I want, because this is also all multiplication. 3 times 3 is 9. 10 to the 4th times 10 to the 4th. Remember when we multiply exponents with the same base, we just add the exponents. So how many breaths do you take in your life? 9 times 10 to the 8th. Excuse me. So you can write it like this, or you can say that in your lifetime, you put a 9, you add 8 zeros, you will breathe 900 million breaths in your life. 900 million times you'll breathe in your life. So start the countdown. Okay, hopefully you can see how I did the math. Doing the math side, this part in green is the most important part today. I hope you can change this into this. Looking at the exit ticket for the day. Most English-speaking countries use the short scale naming system, where a trillion looks like this. So in the short scale, like the United States uses the short scale, this is a trillion. In the long scale naming system, I do not know which countries use that. Maybe you could research that and let me know later. The long scale naming system, this is a trillion. Much, much bigger. Much, much bigger. Well, how many times bigger is the long scale? How many times bigger? So when you do long scale divided by short scale to figure out how many times bigger. Could type all that into a calculator. It would be super annoying. Or you can just say, wait a second. The long scale has 21 zeros. So that is just 10 to the 21st. This is a trillion in long scale. A trillion in short scale is 10 to the 12th. Because there's 12 zeros in short scale. And now I don't have to type all this into a calculator. Now I just use an exponent rule. 21 minus 12, and I figure out that long scale is 10 to the 9th times greater. Long scale is 10 to the 9th times greater. That's much, much greater, and this could have taken us a super long time, except for that we know how to change these into exponents, and we know how to divide with exponents. So this is helpful, helps us solve problems faster. The homework helper is always useful. It'll give you advice, it'll give you hints, it'll show you things again with more examples. Make sure if you get stuck, you also use the homework helper. Finally, we have the problem set. The problem set has 4 questions practicing these skills. Pause the video, do what you can on the problem set, and then come back to me when you are ready to check your answers and discuss. Okay, let us check the answers for the problem set. For number 1, I'm going to do my problem set on a separate piece of paper because I like to spread out and make some room. The Atlantic Ocean contains that much water. Lake Ontario has that much water. How many Lake Ontarios fit inside the Atlantic Ocean? So for number 1, I need to do the Atlantic divided by Lake Ontario. Well, the Atlantic, they tell me, is 2 times 10 to the 16th. Lake Ontario is that number. But you know how to change that into an exponent to make it easier. This is, what number is that? That looks like it's 8 trillion. So we do 8 times 1 trillion. And 1 trillion is 10 to the 12th. So we get 8 times 10 to the 12th. Much shorter to write. Much easier to do the math too. Separate this out. 2 over 8 times 10 to the 16th over 10 to the 12th. Going to move on to the next line. 2 over 8 simplifies to 1/4. 10 to the 16th over 10 to the 12th, we just subtract the exponents because the bases are the same. 1/4 is 0.25 in decimal form. 16 minus 12 means we have 10 to the 4th. Now remember, there are 4 tens, so we jump 4 place values. 1, 2, 3, 4. 4 tens means 4 place values. The decimal jumps over here. these empty spaces, put zeros. So, how many Ontarios fit in the Atlantic Ocean? 2,500 Ontarios in the Atlantic. That's your answer for number 1. Moving on to number 2. The U.S. National Forests cover 300,000 square miles. Conservationists want the total square footage of the forest to be 300,000 squared miles. When Ivana used her phone to do the calculation, her screen showed this. What does that answer mean? Well, okay. Number 2, part A. That 9e plus 10 means 9 times 10 to the 10th. 9e plus 10 means that. Let me show you why. Because what Ivana was trying to do, she was doing 300,000 squared, which is 300,000 times 300,000. And 300,000 is 3 times 100,000. And it's also, the other one is also 3 times 100,000, which is 3 times 10 to the 5th times 3 times 10 to the 5th. And I'm going to use my commutative and associative properties again to do what I want to do, because it's all multiplication. Oh, I'm sorry, I gave away the answer. These should be 3 times 3. It's 9 times 10 to the 5 plus 5, which is 9 times 10 to the 10th. Calculators just don't write all of that. Calculators just put this, but they mean the same thing. Part B of number 2, given that the U.S. has approximately 4 million square miles of land, is that a reasonable goal? So, conservationists want this much land saved in the United States. But the United States has 4 million square miles of land. So does this number fit inside 4 million? Well, 4 million looks like this, which is 4 times 1 million, which is 4 times 10 to the 6th. That does not look reasonable to me, because the United States has this much land. Conservationists want to save this much land. This is 10 to the 10th. Remember, bigger exponents means bigger numbers. How can the conservationists save this much land? We don't even have that much. 10 to the 10th is much, much bigger than 10 to the 6th. They cannot save this much land because that much land does not exist. The United States only has this much. So, conservationists are not being reasonable, because 9 times 10 to the 10th is larger than 4 times 10 to the 6th. That is more land than the U.S. has. We cannot save that much land because we don't have it. This is how much they want to save. This is how much we have. It's like if you want to save $5, but you have $2. Impossible. Okay, moving on to number 3. Checking your work that you've already done. The United States is responsible for about 20,000 kilograms of carbon emission pollution each year. Express the number as a single-digit integer times a power of 10, which means a number times a place value. So, we have 20,000. They want to change that to exponent notation. So that is 2 times 10,000. And 10,000 is 10 to the 4th. There we go. 20,000, 20,000, 20,000. Just looks different, helps us do math. Now, number 4 is saying the United Kingdom, or the UK, is responsible for 1 times 10 to the 4th kilograms of carbon emission pollution each year. Which country is responsible for greater pollution each year, and by how much? So number 4, the US, we solved in number 3, 2 times 10 to the 4th. The UK, if you look at number 4 tells you it's 1 times 10 to the 4th. Which one's greater? Well, both exponents are the same, so we look at the numbers. 2 is bigger than 1, so the United States has more pollution than the United Kingdom. But how much more? How many times more? To solve this, let's divide the US by the UK and see how many times more pollution we get. Split up, we get 2 over 1 times 10 to the 4th over 10 to the 4th. Well, 2 divided by 1 is 2. 10 to the 4th divided by 10 to the 4th. A number divided by itself is always 1. So we get 2. So the US produces 2 times as much, or twice as much, as the UK. That's our answer, number 4. A lot of math today. I hope you're able to follow along with all of it and do the math. Even if you did not know how to set up the problems, set up the equations, I hope you could solve it after I set it up for you. Please keep practicing. Check the other videos. Check Khan Academy and MobiMax for some extra work on this. Also, Lesson 8. At the beginning of your Lesson 8, there should have been something called sprints. The sprints are excellent tools to practice your exponent skills. Practice the sprints, please. It'll make you better with your exponent rules. Practice, study, review. I'll see you tomorrow for the next lesson.